the diameters in what dimension?
30 seconds.
30 seconds of an inch. So if I want to pick out a rivet diameter with a clean sheet of paper, and I'm given no other information other than my material thickness, I'm going to take my thickest sheet and do what with it? 3 times your thickest sheet will give you the rivet diameter. If it's not already given to you. Obviously it's specified in a blueprint. Somewhere that's what you use, but for a test question, we want to find out what a rivet diameter is 3 times the thickest sheet. So now we have the diameter, how do we figure out the length?
1.5 times.
1.5 centimeters.
All right, so we got the diameter. Take the rivet diameter, do what with it?
1.5.
And then do what? Add to it
The thickness of the metal.
total metal thickness. So it's 2 sheets of 040, you add those up. Another sheet of 050, you add all that up, you add that to it, and that gives you your thickness. So my diameter is going to be in 30 seconds, right? And my metal is in decimals. So how do I cope with that? I'm going to convert this to a decimal. Divide 4 by 32, get a decimal, add that all up. Gonna add that all up, and then do what with that? Take it times 16, because the rivet lengths are in 16ths. And then round it. Somebody do that math for me? Doesn't matter. Well, that's because it only comes out to that because I didn't multiply that by 1.5. You gotta take 4 seconds, multiply by 1.5. I say it ought to come out to about a 5. Come out a little over 5, round it down. But I want you to be familiar with the process. Start out by taking your rivet diameter and convert it to a decimal. And then bring that over there, add that up. And whenever you get there, take it times 16 and round it to the nearest. Up or down. Now over here, you always round your diameters up. Did I lose anybody in that process? You gotta know to do that. If you don't know how to do that, you're gonna be missing some questions on the test. of thumb. To find the rivet diameter, take the thickest sheet of metal, so if you're riveting together 0.040, 0.040, and 0.050, take your thickest sheet, which would be 050, multiply by 3. That would be 5 is 15. Don't know what that's going to come out to, either a 4 or a 5, I'm not sure. Real good at doing math in my head. But in reality, Eric, you probably very rarely have to do that. But for the purpose of the test, you need to be able to spit back the correct answer. And you won't have, at least not on my test, you won't have to do that calculation, but you do have to know the fact. Alright? If you really had to do that, then you take that 150 and you multiply it by, so rivet diameters are in what fraction? Alright, so you take 1.150, multiply it by 32, you should get something pretty close to 5.
4.8.
4.8, so you round that up to 5. If you really had to do it, you won't have to do that calculation for the test, but you do need to know the fact. So that's rabbit trail, courtesy of Eric. So when we drive a rivet, we got a rivet shank. As we already covered, we multiply the rivet diameter times what? 1.5. And that gives us a rivet shank that's going to protrude through the metal 1.5 times the diameter. We're going to bump that, and we want to get a shop head that then is 1.5 diameter in width. So we turn 1.5 diameters lengths to 1.5 diameter of width with your bunking bar. And that's the diameter of what? The diameter of the shank. And that part's called the shank. Most rivets that we deal with have a dimple in them. So what does that dimple tell us? Tells us that material is made out of 2117 T3. We'll have the designation of AD. An AN 470 AD or an MS 2470 AD. Tells us that, that's what that dimple tells us. The material, the 2117 T3 aluminum. When it's written out, it'll have the letter designation AD. What that means, We can pull these out of the bucket and dry them, because they are already properly tempered and heat treated at the factory. And they don't age or work harden until you buck them. Once you buck them, you induce work hardening into them. Remember that safety wire that you bent around the turnbuckle? You wanted to try to unbend it a little bit, and it didn't unbend, did it? Of course, some of you never had that problem because you bent very well the first time. But if you try to unbend that wire, it don't want to unbend because you work hardening, and rivets will work harden. As soon as you buck them, they start that work hardening process. You come back tomorrow, say, hey, gee, I'd like to drive that a little more. Boy, you've got a bear on your hands, because that material will work harden. So while we're on the subject of rivet materials, there's a 2017 D and a 2024 DD. These are called icebox rivets. Now, the benefit of them is they are a harder rivet. So some applications call for a harder, stronger rivet. But once they are heat treated at the factory, they gotta throw them in a freezer. And they're gonna ship them to you, they ship them in dry ice, and you gotta keep them in the freezer. Because just like you remember when we were doing the carbon fiber, pre-pricks, we threw them in the freezer. If they're in the freezer, they stay frozen, you can pull it out and use it. But once you pull it out, you need to use it, because then that hardening process will begin. And so if you don't use these right away, you gotta reheat treat them, and then put them back in the freezer until you're ready to use them. Called icebox rivets. And all of them are called age hardened. To reach strength. That is, after you buck them, in time, they're gonna get harder. I don't know why I'm not a metallurgist. I don't understand the process. Don't care. Don't have to understand the process. I just have to know that it works. I don't have to know how this cell phone works when I turn it on. Don't care. Just care that it does. The same thing with a rivet. When you drive it, it's going to be age hardened. If it's an icebox rivet, you take it out of the icebox and you don't use it, it's going to age harden. Or the 2117s, you can store in a box forever. So I could put some in the box today, wait till he's 65, pull them out, use them, and they'll work just fine. We're going to do a rivet layout. We got an edge of a piece of metal. What's our minimum edge distance in terms of the rivet diameter?
Times 2, 2D.
Minimum edge distance.
2D.
2D, the minimum airworthy legal edge distance. Do you want to shoot for that? No. But you need to know that the minimum is 2. Spacing between adjacent rivets in the same row is called what? Pitch. What's the minimum acceptable pitch for airworthiness? 3D. What's the maximum?
12.
that's on the test. I mean, like the FAA test, I don't remember that.
Is it on your test?
Yeah.
That's what we're.
Let me just read you the test. Let's put it this way, if it's on my test, which I don't think it is, and you answer 10 or 12, I'll give it to you, all right?
Google AI says 12, but.
Really?
That's what Google AI says.
What is it? Mine says 10.
Is it really? You looking it up? Does yours really say 10 and yours says
Mine
12?
says the FAA generally considers a maximum rivet pitch of 10 tons of rivet diameter
Yeah.
as acceptable.
That's what I have in my brain.
Mine says according to the FAA, or EAA, that is something as much as 20.
I have probably just one right now.
All right. In any event, we can't get Google in the FAA.
Put it down the middle.
All right. Someone for me pulling facts out of my brain.
Oh, dude, I'm ready.
Ignore the subject, pretend it doesn't exist.
That's
I think
okay.
we'll remember it.
All right, so if I have 2 rows of rivets, what is the distance between the rows called? Gauge. So I got pitch, I got gauge. And your gauge should equal your pitch, unless it's transverse. If it's transverse, it only has to be 75%. Gauge only has to be 75% of pitch.
So what did you say, it had to be 10 from, not transverse?
10 is the maximum of the pitch. 75%.
Gauge should equal pitch. Unless it's transverse,
Yeah.
in which case it's 75%. So if your pitch was 4, your gauge only has to be 3. That you will have to know as well.
And that's gonna be 3 between both the top row and the bottom. Like if we were to use 4 as the pitch, it would be 75%.
3, so if you got another row, that's 3, is that what you're asking?
Yes.
Yeah, it's 3, 3, 3, if you got 18 rows of transverse rivets, it's 75% for each one of them. I just used that as an example, because I could do that math in my head.
Okay.
The 4 and the 3 are only examples, they are not set in stone.
No.
If this was 8, then that would be, I don't know what it is, 6, okay? So the 3 and the 4 were examples, 75% is what you need to know. And you will have to put that to use,
Yeah.
okay? So we put in multiple rivets, and we're taking a look at something that brings an airplane for a repair. And we notice those, we look at rivets, and we looked at them all kind of bent in the same direction, tipped in the same direction. That would be shear failure. Because the rivet's going to tip, 2 pieces of sheet metal together, if they are either pulled apart or compressed together and the rivets are tipped, that's a shear force. So rivets tipped in the same direction are an indication of a shear failure. We use a lot of 2024 T3. If it gets bent, what you gonna do? You can hammer it, straighten it, but then you should reinforce it. For example, some of you took out rivets out of, had a stringer riveted to the skin. You had to take rivets out and wound up getting bent out. What we do, we straighten it with a hammer, and then we should reinforce it. Now we were putting that stringer in as a reinforcement, or you could use a doubler. So it should be straightened with a hammer, plus reinforced by some method. Either like we did with the stringer, that would count as a reinforcement, or you could use a doubler. The joggle doubler that we put in would qualify. Why do we use a joggle? Why do we bother using a joggle?
When there's a lap,
Because we got something that's in the way. And so you want to allow for clearance. Something's in the way. So again, you should know that your 470 rivets are your universal heads. What are your 426s? The countersunk. So when we're measuring rivet lengths, on a universal head rivet, we start measuring the length there at the base of the head. And the thickness of that head does not count as a rivet length. However, when we're dealing with a countersunk rivet, the length of the rivet is the entire rivet from top to bottom. If we're going to drive a universal head rivet, our rivet set will be slightly larger across than the rivet itself. Is that right? My fifth grade art teacher would be rolling over in her grave. That's awful. You get what I mean? It's just slightly larger. You won't have any pictures, you just gotta know it's slightly larger.
I think you should give us a hand-drawn picture on that.
Oh, man.
You guys pick the right one.
Then you complain to the FAA. Oh, you may get a picture. I get rid of this before anybody takes a picture of it and uses it against me. Countersunk rivets. Let's see if I get a different color here. especially if I'm going through metal and that top piece is thin. And I got a countersunk rivet. That countersink should not penetrate through that top layer. So that would be unairworthy, because that countersunk angled part of that rivet extends through the top sheet of metal. That would be considered unacceptable. If it sets right about there, that's okay. Ideally, should look something like that. But either that or that are acceptable. That, no bueno. Back to 2024 T3. Shouldn't want to scratch it. Don't want to beat it up like some of you beat up the 2024 T3. You also don't want to use a scribe to mark your line where you're going to bend it. You only use a scribe to mark metal if you're going to cut it along that scribe line. Because this 2024 T3 is what clad is called clad. That is, it's an alloy except for the surface layer, where they press on a very thin layer of pure aluminum. And they do that for corrosion resistance purposes. And so if you scratch it, which you shouldn't do, but if you do, and I never had much success at this process, occasionally I do, most of the time it just scratches it some more. The corrective process is called burnishing, and that's where you just kind of press it instead of polishing it. You need to spit that word back on the test. If it's scratched up, you correct it by burnishing. But you shouldn't scratch it in the first place, so there you go. Most of what we dealt with is aluminum, but there are some components of an aircraft that are made of steel. If you're going to rivet steel, what kind of rivet do you think you want to use? Steel rivets. Blah, 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 blah. If you got magnesium, magnesium doesn't make very good rivets. But we do have an aluminum alloy called 5056 aluminum, which is an aluminum magnesium alloy. And so if you have to rivet magnesium, you should use that rivet, which is a 5056, which is an aluminum magnesium alloy. But if for some reason you have to use a riveting situation where you have dissimilar metals, you should provide some layer of insulation between those layers. Usually that would be in the form of like a Teflon or something like that. But if you're, why? Because of corrosion. Dissimilar metals will corrode. So some sort of insulation has to be placed between any dissimilar metals, whether it's two metals that are dissimilar or even a rivet and a metal that are dissimilar. There must be some sort of insulation. Bending metal. We've all had the privilege of laying out metal. We lay out flat A. And then you got your bend radius. You should put your sight line. Where? One radius from that bend tangent line. One radius. Is where you locate the sight line. If you're going to bend metal, which way do you want the grain? You want the grain running that way, which is at 90 degrees to your bend. That's your bend, that's your grain. It's 90 degrees. Grain should run 90 degrees to your bend. Once we bend it, so we talked about radius. Radius is always measured from the inside. If they tell you they want a 3/16 inch radius, they're talking about the measurement of the inside. And right down the middle here somewhere is called the neutral line. Because the inside part of this is under compression, the outside under tension. Should know how to do a bend radius problem. We had a quiz. Some of you did very well, some of you didn't do very well. If you didn't do very well, you better figure it out before Tuesday. Because you will have bend radius problems, and you'll find it difficult to make a good grade if you don't know how to do them. Because there's a lot of answers. You've got the same problem, you got a flat, a bend allowance, total developed width, and you don't do them.
We have the formulas in the chart.
Formula will be provided if you need a K factor. K factor will either be provided or the chart gets to you. If it's a 90-degree bend, you're expected to know that K factor is 1. That may not be given to you. So, if they say this is bent to an inside angle of 45 degrees, the key word there being in the inside angle, how far are we actually bending that metal? Yep, we start with a flat piece of metal, which was out here, and we're bending it all the way around to there, which would be 135 degrees. So, I'm not gonna mess with you on the test. The FAA may mess with you on a test, but you do need to be able to do that calculation and know that if they ask you, how much are you bending, and they give you an inside angle, you need to know that you're actually bending that through a much larger, whatever total would come up to 180 degrees. So if this were 35, this would be 145, because that total then is gonna equal 180 degrees. Fasteners, high locks are installed how?
Ordinary hand tools.
Ordinary hand tools. Cherry max are installed how?
A special pulling.
Installed a special pulling tool. Usually that's a pneumatic gun, but there are hand squeezed Cherry Max pullers, which I don't think we even have one. We might in the archive somewhere. I'm not interested in using it. We have the pneumatic guns, but you can't say a special pneumatic gun because there are hand pulling guns. So you're pulling that stem, regardless of whether you're doing it by hand or by a pneumatic tool. So the correct answer is a pulling tool. Lock bolts come in two varieties.
Shear and tension.
Shear, tension. How do you tell the difference?
The amount out there.
Locking grooves. Which has how many?
Shear has two, shear has four.
Shear has 2, tension has 4. Again, my way of remembering that is tension is the bigger word. Wahoo. Alright, that's about it. I don't know whether our rib nuts have come in or not, so for those of you who are still pending, installation of those, stand by downstairs.